Although humanity has yet to send a crewed mission beyond Earth, we've already made extraordinary progress in unraveling the mysteries of the cosmos. The universe spanning vast galaxies, the very fabric of space-time, and even the origins of life remains a realm largely shaped by theories and speculation. That's why missions like Voyager 1 have been so vital. These robotic explorers have provided crucial data that move us from guesswork to evidence-based understanding. Voyager 1, in particular, has taken us farther than any spacecraft before, exploring the far edges of our solar system and pushing ever closer to the unknown. However, after decades of reliable performance, Voyager 1 has recently begun sending back puzzling and unsettling signals. According to NASA Administrator Bill Nelson, these signals suggest possible contact with mysterious extraterrestrial forces. The scientific community has been stunned, raising pressing questions about what these anomalies might mean for the future of the mission. Launched from Cape Canaveral 45 years ago, the Voyager probes embarked on what would become one of the most remarkable adventures in space exploration. Both spacecraft have since traveled beyond the outer boundaries of our solar system, revolutionizing our understanding of the universe and capturing breathtaking images along the way. Since the late 1970s, Voyager 1 and 2 have been instrumental in studying the gas giants Jupiter, Saturn, Uranus, and Neptune. Built with exceptional engineering, these probes were designed to endure the extreme radiation and environmental hazards near massive planets. Against all odds, they have withstood the bitter cold, intense radiation, and fine cosmic dust of deep space. The Voyager mission reflects the dedication of thousands of scientists and engineers, totaling roughly 11,000 man-years of effort. Originally intended to study the outer planets, the Voyager probes exceeded expectations, sending back astonishing images and revealing secrets from distant worlds. From capturing the iconic pale blue dot image of Earth to detecting volcanic eruptions on Io, the Voyagers have expanded our sense of wonder and understanding. While not the first probes to venture so far, Voyager 1 and 2 were purpose-built for deep space exploration, building upon the path paved by earlier missions like Pioneer 10. Every component of these spacecraft was meticulously engineered to endure the dangers of space while maintaining the integrity of their scientific instruments. Voyager 1 was especially outfitted for the long haul, equipped with sophisticated tools and communication systems to keep it connected to Earth even beyond the solar system's edge. A standout feature is its 12-foot high-gain antenna, capable of transmitting signals across billions of kilometers to NASA's Deep Space Network, a global system of stations in the US, Spain, and Australia. This setup ensures that Voyager 1 remains in touch no matter Earth position. It also carries a digital recorder that stores up to 67 gigabytes of data, safeguarding information even when immediate transmission isn't possible. To maintain alignment with Earth, Voyager 1 relies on a complex network of thrusters, gyroscopes, and reference sensors. These systems are crucial, especially in the outer solar system, where high-speed particles can push the probe off course. Powering all of this is another engineering marvel: 3 radioisotope thermoelectric generators, RTGs, that convert the heat from decaying plutonium-238 into electricity. Unlike earlier missions that depended on solar power, Voyager 1 continues to function even in the coldest, darkest regions of space, thanks to these RTGs. After its 1977 launch, Voyager 1 passed Mars' orbit and reached Jupiter in March 1979, beginning a detailed survey of the planet and its many moons. It captured high-resolution images, mapped magnetic fields, studied radiation belts, and provided the first close-up view of the Great Red Spot, a storm larger than Earth. One of its most groundbreaking discoveries came with the detection of active volcanoes on Io, the first time volcanic activity had ever been observed beyond Earth. In November 1980, Voyager 1 made history again by becoming the first spacecraft to fly past Saturn, offering unprecedented views of its intricate ring system and powerful atmospheric winds, which were clocked at 1,100 miles per hour. The probe's encounters with Saturn's moons, including Titan, Hyperion, and Enceladus, revealed new and unexpected features. Its close approach to Titan was especially groundbreaking, uncovering a thick atmosphere and providing hints of liquid hydrocarbon lakes and cloud formations. Voyager 1's instruments collected invaluable data about Titan's atmosphere, helping scientists better understand its composition and laying the groundwork for future exploration. Through all these achievements, Voyager 1 has not only redefined what robotic missions can accomplish, but it continues to challenge our understanding of space with each signal it sends from the edge of the unknown. As the Voyager 1 mission progressed toward the outer edges of the solar system, NASA began shutting down non-essential systems to conserve power, including the spacecraft's cameras. Before they were turned off, however, Voyager 1 captured the iconic family portrait of the solar system in 1990, which famously included Earth as a tiny, fragile speck of pale blue dot. This image, showing our planet as less than a pixel in size, powerfully emphasized Earth's smallness and the vastness of the cosmos and became a lasting symbol of our shared home, unity, and the importance of exploration. Even after its cameras went dark, Voyager 1 continued transmitting valuable data as it ventured deeper into interstellar space. Its instruments recorded surprising features at the boundary of the solar system, such as an unexpectedly strong magnetic field of the heliopause and a plasma region believed to shield the solar system from harmful cosmic rays. Scientists are still studying these discoveries to understand their role in protecting Earth and shaping future deep space missions. Some researchers even suggest that the heliosphere, once believed to resemble a comet's tail, might instead take on a croissant or donut-like shape, with gaps that could potentially allow safer passage for future explorers. These insights have reshaped our understanding of the solar system's edge and fueled a renewed drive to map it more accurately. Voyager 1's extraordinary journey has profoundly influenced how we perceive the universe and continues to inspire humanity's quest to unlock the secrets of the stars. Its discoveries are crucial to deepening our understanding of a transitional region between the solar system and interstellar space. The heliosphere's magnetic field appears to interact directly with the broader cosmic environment, suggesting an active relationship between our solar system and the universe beyond. This breakthrough has opened new avenues for scientific inquiry and prompted fresh questions about this mysterious boundary. When Voyager 1 officially crossed into interstellar space in 2012, it marked a historic milestone in human space exploration. Since then, every transmission from the spacecraft has been eagerly anticipated, offering rare glimpses into an area once thought unreachable. Recently, however, the probe began sending back puzzling and unexpected signals that challenged existing scientific models. These anomalies caught the attention of NASA's Jet Propulsion Laboratory, as the data described conditions in interstellar space that defied known expectations. Scientists were confronted with the challenge of interpreting these strange readings and understanding their implications. After thorough investigation, experts traced the problem to Voyager 1's Attitude Articulation and Control System, AACS, which ensures that the spacecraft's antenna stays properly oriented to maintain communication with Earth. Curiously, while the AACS appeared to be functioning normally and the spacecraft continued collecting data, the signals being sent were distorted and nonsensical. Engineers eventually discovered that the AACS had mistakenly begun routing data through a long-defunct computer system that hadn't been used in years. Though the scientific data itself remained accurate, passing it through this inactive system corrupted the signals. Once the issue was identified, NASA quickly responded by instructing Voyager 1 to bypass the faulty system and resume transmissions through its operational channels. The fix worked, and accurate, reliable data from interstellar space began flowing once again, renewing our connection to the farthest human-made object in the universe and continuing its legacy of groundbreaking discovery. As Voyager 1 continues its mission into the depths of space, it remains a crucial source of insight into the mysteries of the cosmos. Although mission controllers believe a recent technical issue was a one-time error, it highlights the immense challenges and uncertainties involved in exploring the farthest reaches of our solar system. Voyager 2, which entered interstellar space in 2018, may encounter similar obstacles as it continues its journey away from Earth. Originally designed to last just 5 years, both spacecraft have defied expectations with more than 45 years of continuous operation, a testament to the resilience of their engineering and the brilliance of the minds behind them. Despite their age, NASA remains hopeful that both Voyagers will continue transmitting data into 2025, with Voyager 1 expected to operate for a few more years before its power source is depleted. Looking ahead, Voyager 1 is projected to enter the Oort cloud in about 300 years of vast, icy region at the edge of our solar system, and it may take 30,000 years to traverse it fully. In an even more distant future, approximately 40,000 years from now, Voyager 1 will pass closer to the star Gliese 445 than to our own Sunday. Around the same time, Voyager 2 will come within 1.7 light-years of the red dwarf Ross 248 in the Andromeda constellation. As these silent travelers continue their eternal voyage, they will bear witness to the slow evolution of the galaxy. Over the next 230 million years, our solar system will complete one full orbit around the Milky Way center, and by then, the galaxy's spiral arms may have shifted dramatically, perhaps even due to a future collision with the Andromeda galaxy. One of the most compelling aspects of Voyager 1's journey is the golden record it carries, a time capsule featuring greetings in multiple languages, natural sounds, and music from around the world. If encountered by intelligent life, this record would serve as a profound introduction to the diversity and creativity of human civilization. The Voyager missions have become enduring symbols of human curiosity and the relentless pursuit of knowledge. They have forever changed how we perceive our place in the universe, inspiring generations of scientists, dreamers, and explorers. Launched in 1977 with the initial goal of studying the outer planets Jupiter, Saturn, Uranus, and Neptune, Voyager's mission evolved into humanity's first venture into interstellar space. Each mile they travel extends a frontier of human understanding. It is humbling to realize that the Voyagers are now farther from Earth than any man-made object in history. A single radio signal takes over 22 hours to reach Voyager 1, and another 22 hours for its reply to return. Yet, despite these immense distances, the spacecraft still faithfully send back data, connecting us to the edge of our solar neighborhood. The technical challenges they face, ranging from radiation and micrometeoroid impacts to the wear of time, remind us of the harshness of space. But the teams at NASA continue to meet these obstacles with innovation and dedication, managing to keep these aging explorers functional against all odds. Beyond their scientific contributions, the Voyagers carry deep symbolic value. The golden records they bear are not merely instruments. They are cultural artifacts offering a glimpse into who we were when we first reached out to the stars. Their sounds and messages serve as an offering of peace and curiosity to any civilization that might one day encounter them. The lessons learned from managing the Voyager missions are already influencing the design of future deep space missions, including those aimed at the icy moons of the outer planets or even interstellar destinations. Though their instruments will eventually go silent, the Voyagers will drift through the galaxy for millions of years, tiny emissaries of Earth, perhaps outliving even humanity itself. As we reflect on their journey, we are reminded that exploration lies at the core of the human spirit. Built with 1970s technology but driven by an enduring curiosity, the Voyager spacecraft continue to push the boundaries of our knowledge and imagination. Their legacy will echo across time, shaping our understanding of the cosmos and inspiring all who dare to dream of the stars. Ask ChatGPT.